Hey everyone, my name is Phil Reyneri. I have worked across the tech and art and entertainment industries for about 10 years now. People typically refer to me as a creative technologist. I specialize a lot in AR, VR, interaction design, and specifically I've done quite a bit of projection mapping, which is what this talk will be about. I'm now with a company called Lightform, which makes hardware and software for projection mapping. We call it projected AR, and I will explain a little bit about that in a minute. So, just going to do a quick background on myself. I got started at a company called Obscura Digital in San Francisco. They happened to move in across the street from me, and I just walked in the front door and asked for an internship one day. They kind of introduced me to this world of large-scale immersive entertainment. While I was there, I worked on projects ranging from the YouTube Symphony Orchestra, where we mapped the Sydney Opera House, and the Guggenheim in New York. I later went on to tour with Skrillex and a few other musicians, so I designed his first major production in 2011. It was kind of this motion capture-enabled, projection-mapped set piece that was kind of akin to the Emon Tobin ISAM show that was touring around the same time. We actually worked with a lot of the same folks on that. And also did a fair amount of festival installations, including one at Coachella and a couple for the musician Flying Lotus. And in 2013, I went to work for Bot and Dolly. This is a shot from the short film Box, where I did the projection mapping and lighting design. And before I talk about Box, I just want to get this out of the way, because I think this is becoming a bit of a meme. So G-Monk is actually my housemate, and I promise this is not some sort of like FITC nepotism while I'm here, but he did convince Sean to come to my talk at South by Southwest, so I have to thank Bradley for that. And next year, if you'd like, I'll do a whole talk about what it's like being his roommate. Oh yeah, he wants to let you know that he's currently in a fog box shooting lasers, so he's being Bradley. So projection mapping. I don't particularly love this term because it's a verb that refers to a specific action within projection, the actual like physical manual mapping of pixels to a real object. Oop. This is what happens when you build your slides 2 minutes before the presentation. Okay. Anyway, that's a slide that basically depicts, actual warping of vertices around. So when you start projection mapping, you start with something like this, basically a black screen. Oh, you can see it now. So when you're actually creating content, you're going around and you're kind of taking your video assets and you're mapping them manually to the world. And, it doesn't really describe the final output, which is the experience that you create. Also, when you hear the term projection mapping, you tend to think of these big budget experiences like Box and these kind of expensive brand activations, these Trump Louis forced perspective, making buildings crumble. And then on the other end, you might think of a typical kind of low poly faceted stage design that you might see at like a warehouse party or at Burning Man. And kind of between these two extremes, there isn't really anything that exists outside of the entertainment industry. The tools and the technology kind of promote this. The software has a relatively steep learning curve. The hardware is still quite expensive. And there isn't really something out there yet that would enable this to exist in a more common scenario. So that's really what we're about at Lightform. And we use projected AR to describe a form of projection that is more automated. So the user would actually spend less time doing mapping and more time actually creating content. We use computer vision to enable this, and I'll talk about that in a little bit. We're globally aiming to democratize this medium to bring the price down, to make it more accessible to designers of every type, not just your creative technologists and motion designers. But we still do want to maintain a little bit of that concert and like theme park magic. So before I get into projected AR, I'm going to talk a little bit about our mortal enemy, screens. But this is a different kind of screen. This is the Electric Objects EO1, a product I backed on Kickstarter in 2014 that promised to bring digital art into everyone's living rooms. Show of hands, who here backed this or owned one of these at some point? Okay, like a few. Early adopters. So the product, despite appearing to be just a computer rotated 90 degrees, had some really incredible ideas behind it. There's this enormous amount of digital video and interactive art on the internet, but it currently only exists within our phones or our laptops. There, it lives between dozens of browser tabs, hundreds of notifications, and other apps. And it's usually a passive experience where we view and sometimes comment, but it doesn't provide us much value beyond the split second we scroll past it. But electric objects, they were trying to change that. They sought to take this, experience that we had in these very general purpose computing devices where we could, get distracted by a million other things, and then give it its own dedicated physical embodiment where it was beautiful enough to hang on your wall. You couldn't get a text message or you couldn't get an email while you were looking at the device. It basically just did one thing, display digital art. And yes, there were plenty of distracting cat GIFs and memes that you didn't necessarily want in an endless loop on your wall. But there was this specific type of content that I found particularly interesting, generative content that pulled data from the internet. This is another digital art display called Framed 2.0. Framed could render Open Frameworks apps, which meant that it could render more real-time and interactive content. Two examples of this included Nicholas Felton's Bike Cycle, which visualized Manhattan's public bike share program, and Aaron Koblin's Flight Patterns, which visualized flight data. Both of these data visualization artworks were kind of stuck representing a single window of time. So there was like a year's worth of data that they would represent. There wasn't a UI that you could connect your own data source, but if there were, then the art could basically be personalized. So the artwork could be beautiful, but also functional. Because they were connected to the internet, they could provide relevant, real-time information to the viewer. For example, is my loved one's flight delayed, or how far away is my Uber, or simply what is the weather forecast? But instead of constantly referencing our phones for this information, where we have this tendency to get sucked into other apps and distractions, we can passively obtain this data in a more ambient fashion. The data is actually built into our environment, this concept of like media architecture. So as computing miniaturizes, we've started filling our spaces with all of these Bluetooth and Wi-Fi enabled devices. Everything down to our toothbrushes are now smart. So it seems that physical art and design objects are kind of destined to eventually become a part of this Internet of Things. Internet-connected hardware is this new medium, really, that blurs the lines between decorative and functional, between artwork and computing interface. This is the NYC train sign, a retro-inspired dot matrix display that visualizes your local train or bus times. This is an Android-powered smart beer by Max Braun that simply displays the weather and news headlines. And when off, the mirror would just return to a normal state. This is a patch of sky, an LED sculpture that visualizes the weather. And this is Vestaboard, an internet-connected mechanical split-flap display that makes those satisfying clicking noises as it updates, kind of like the Grand Central Station. This is Goodnight Lamp, a pair of internet-connected nightlights that sync together over the internet. So they're able to create a sense of connection with a faraway loved one. So when one light turns on, the other one's on, and you know that someone is awake. So these internet-connected devices blur the line between design objects and computing interface. Yes, you could obtain all of this information from your smartphone and from social media, but you didn't have to. And while the information conveyed is fairly limited, that is kind of the entire point. So a trend you may be hearing about a bit this year is the concept of calm technology. Who here has heard this term thrown around a bit? Okay, sorry, I'm doing a lot of show of hands, just curious. So calm technology describes a form of technology where the interactions can exist in the periphery of our attention, not always requiring 100% of our mental bandwidth. A good example of this is Google Home or voice assistant, like Alexa. So they're there when you need them and invisible when you don't. But calm tech can also be dead simple. Good examples of this include a lavatory light on an airplane or a wall clock. They're not distracting, they're not demanding your attention, and you only need to consult them when necessary. So most objects in our homes kind of currently exist in the periphery of our attention. They're not, beeping at us, hopefully, too much of the time, demanding our attention. But as they become increasingly digitized, as we start to embed microchips into every little object that we own, are they going to stay in the periphery of our attention, or are they going to become, as distracting as these devices? Jake Levine, the founder of Electric Objects, the digital art display that I first mentioned, he believed that we could maintain, internet-connected hardware that is not distracting. He spoke frequently about making computers that don't demand your attention, a reference to this concept of calm technology. The term calm technology was originally coined by Xerox PARC researchers Mark Weiser and John Seely Brown in 1995. They were both early pioneers of ubiquitous computing, which is a closely related concept. The concept was further developed by Amber Case in her 2016 book by the same name. This is a great quote from her, so I'll just read it. Technology shouldn't require all of our attention, just some of it, and only when necessary. So I believe that calm technology is a reaction to our increasing addiction to technology. We have these endlessly distracting news and social media feeds. You have Apple's investors writing their board of directors saying, you need to do something about our kids being addicted to their iPads. We now even have products like the Lightphone, an anti-technology dumb phone intended as a temporary stand-in for your smartphone. But are more devices actually the ironic solution to technology overload? All right, one more, raise your hands. I think this is my last one. How many of you find yourselves checking your phone for one purpose, but then get sucked into another app? Yeah, okay, everybody. Yeah, I do this all the time. I've tried to turn most of my notifications off, but I kept Instagram on, and it's just it gets me every time. I have to read you this amazing quote from John Herman. This is an article titled "How Tiny Red Dots Took Over Your Life," a reference to the little notification badges we see on our apps. Dots are deceptively, insidiously simple, but they imbue whatever they touch with a spirit of urgency, reminding us that behind each otherwise static icon is unfinished business. They don't so much inform us or guide us as correct us. You're looking there, but you should be looking here. They're a lawn that must be mowed, boils that must be lanced, or at least scabs that itch to be picked. They're bubble wrap laid over your entire digital existence. I think that quote is amazing. So all of these objects I just mentioned, while they were conveying simple information in a beautiful, elegant way, one of the best things about them, there were no red dots. Okay, so I want to talk about projection as a calm technology. Projection, I believe, is an inherently calm display technology because it can disappear. It can be used to augment existing analog objects in subtle ways that don't distract and don't overwhelm. This is an example that I created in my kitchen. It's a marble wall clock that I got from EQ3. It's just a simple analog object, but I added projected light to it that when I walked in the morning, it would actually automatically display my local commute time. So I was able to actually make a coffee, and I didn't have to take out my phone, unlock it, open Google Maps, type in an address, check all of it. I could actually continue doing whatever I was doing and then just look up at the wall and see it there. So it was kind of this contextually relevant information that was there when I needed it, off when I didn't. Similarly, this is a laser-etched map of San Francisco made by Lawrence Srinivasan. It's just a hunk of cork and plywood. There's nothing smart or digital about it, but it looks nice on my wall. But if I were to hail a lift with my phone or voice assistant, I could turn it into a illuminated, contextually aware display. So I could just continue tying my shoes and simply had to look up to see how far away my lift was. Here's a quick video of that demo in action.
Okay, Google, get me a ride to Trouble Coffee.
Okay, your lift will arrive in 3 minutes.
And yeah, you can call me out. I made the destination all the way across San Francisco, so it would be visually appealing. But anyway, this is another fun example, playing poker. So you can imagine, your Settlers of Catan board being mapped or any sort of tabletop game. So there's this other relevant trend that I think is simultaneously going on. And that's the resurgence in popularity of vintage analog media like books and vinyl records. A lot of people attribute this to a backlash against digital technology. But David Sachs writes that the resurgence in popularity of vintage media like Polaroid and books and vinyl isn't necessarily that we're sick of digital or just feeling nostalgic. It's that maybe we've just gone too digital and that we crave more tangible experiences balanced with the digital ones. I recently bought this vintage Pioneer amp off eBay, and the sound is okay. It's like it's nice, but really my favorite thing about it is the satisfaction you get from flipping the mechanical switches or like turning the knob. It's like this hunk of metal with like really nice detents, and it's just something that you don't really get from a screen or a smartphone. After all, we are physical beings. We appreciate tactile experiences. It's actually pleasurable to hold a nice book in your hand or take a record out of its sleeve. So, while I believe products like framed and electric objects are totally on the right track, bringing internet-connected art and information into our lives in a subtle and visually appealing way, at the end of the day, they are still just screens. They're flat windows into a purely digital world. But the world is not flat, as some conspiracy theorists would have you believe. The world is not a desktop. This phrase was made popular by Mark Weiser and Amber Case. And I think even more specifically, the world is not a screen made of glass and injection molded plastic and circuitry. We have a three-dimensional reality with texture and materials and physical sensations. So I only half-jokingly show this image of Black Mirror, comparing it to a warmer, more natural interior. So the image on the left is obviously a very digital-looking scene, whereas the image on the right is obviously very, analog. What I argue, though, is that the scene on the right can be equally technologically advanced and connected, just using a different display technology. So if you were to turn the digital information in the left image off, you'd be left with just a bunch of black gaping rectangles, whereas the image on the right, you'd be left with the existing architecture and the existing scene. So projection is this incredibly pliable medium which can illuminate pretty much any surface. This is an example of one of our generative effects that we were working on at Lightform. So the idea being that we can actually scan and then do edge detection on very complex surfaces and then immediately map content back on top of it. Projection facilitates tangible interactions, which is a concept pioneered by MIT professor Hiroshi Ishii, where digital information is given a physical form that you can actually reach out and touch. This is, I believe it's called material interfaces. Yeah, so this is like a table basically that could morph and change, but they added projection on top of it, and it was facilitated kind of like a two-way interaction where it could create forms and shapes, and you could then modify them. So light has no volume. Instead of needing a hunk of glass and plastic to render digital content, you can augment existing architecture. So if you're an architect or an interior designer, you can actually just work with an existing material palette as opposed to figuring out where you're going to retrofit a wall to put a screen. So by using projection, we are able to keep our dumb analog surroundings intact, but we can still embed the digital experiences that we desire. Because again, it's not that we don't want the digital, it's just that we don't want it at the expense of the physical. There's a concept called dumb things, smart light, which was coined by Berg, a research firm in London back in 2011. They actually also discovered that projection often looks more interesting on non-white materials, so materials that have color and texture. This is a picture I saw on Instagram from the Airbnb design team. It's from a talk they hosted with Joshua Kesey, a well-known photographer. Does anybody notice anything interesting about this picture? Yeah. Yeah, exactly. And I don't know. I found this pretty fascinating, actually. There's a perfectly good projector screen that's hanging up there, but they opted to not use it. And this could totally be because the projector screen wasn't working or like it had a stain on it. But what I like to think is that we, are so used to seeing our content rendered on these like perfect 5K OLED Retina displays that it's just so pixel perfect, right? There's this novelty to seeing our content rendered in the real world where it's like absorbing the texture and the color of the surroundings. He's a professional photographer. Like, I'm sure he cares very much about how his content's being rendered. But honestly, if you were to pull that screen down, it would just look like this kind of like white, washed out, the ambient light would kill it. And so by just projecting straight onto the wall, it's creating this more integrated experience. So in order to do a lot of the things I was describing previously with, mapping physical objects and putting pixels precisely in the real world, you need to introduce vision. Projectors are not cameras, they can't see. So in order to understand where the pixels are going, you need to somehow map them. Projected AR becomes a content creation problem, but also a computer vision problem. And this is why we're building Lightform. Lightform is a camera and an embedded computer that adds computer vision to most projectors. It will precisely map where the pixels fall in the real world, letting you create content directly on top of it. As I mentioned, projected AR only exists in this kind of limited niche realm of high-end entertainment and PhD research. Box cost us almost $1 million to create. This image on the right is using a really high-end motion capture system to do real-time tracking, and this is kind of the future, which I'll talk about in a little bit, of where projected AR is going. But with Lightform, what we're trying to do is make the medium more accessible to a wider range of users, not just motion designers or creative technologists like us, but any designer, hobbyist, business owner. This is a collaboration we did with Gemma O'Brien, where we had her come and do a mural in our new office. And then we used some of our tools to create an augmented reality kind of lit up mural. And yes, it says it's lit. We're like dying to release this because we're pretty sure that by the time we release it, It's Lit is going to be like, I think it's already dead. This is a projection menu at a cafe across the street from our office in San Francisco. So we worked with Jeff Goodwin, a local designer, to create a three-dimensional sculpture out of wood and metal, which we then map with digitally updatable content. So the barista there can just open up her laptop and change the menu immediately. There's no need to reprint or have somebody come in and do the chalkboard. The sculpture's materials complement the design of the space, and the staff, like I said, can quickly update. So it provides the convenience of having digital signage, but without looking like digital signage. And this is something that we hear a lot from potential retail customers where, putting up screens for signage tends to make you feel a lot like a fast food restaurant. And you'll notice, like, even Starbucks, they don't do it. They've got a system that they're kind of trying to avoid the screen aesthetic generally. So Lightform works by connecting to any normal video projector. Then it projects light patterns through the projector, which are detected by our onboard camera. This process is known as visible structured light, and it relies on kind of principles similar to stereo vision to extract depth data. So once we map all of the projector's pixels, we send this scan to our desktop software, Lightform Creator. So this means that content creation no longer starts with a black screen. You're actually authoring content on directly what the projector sees. And then, of course, with Lightform, when you're actually making the content and you're doing the edits in real time, you're not only seeing it on your screen as you would with a normal photo editing tool, but you're also seeing it in the real world. So mapping all the projector's pixels allows us to do some pretty neat things, such as applying generative content. So here you see the process actually happening in real life. Those are the structured light patterns. And what we're doing is we're actually reprojecting the image back onto the scene. And so this is literally with the click of a button, you can do this Tron effect, we call it, which is a simple edge detection filter. But that content's rendered on the device, so we can do simple things like change the color or change the stroke width. And it took what would have taken 30 minutes to go through and trace all those outlines, only a few seconds. So thanks to the computer vision plus generative effects, the speed by which we can create the content is dramatically increased. This is from a recent Renegade projection mapping trip we did in San Francisco. We made this bike, which we brought out, and we kind of just quickly mapped objects around town. These sculptures were by Hybe Kozo. They're an artist duo that brings them out to Burning Man. And they were throwing this closing party for them. So we actually showed up, used our system to do a scan, and then we can immediately apply content to it. Here's some early shots of some of our software that's currently in development. And as you'll notice, it looks a lot like a photo editing tool. So we have that projector scan as the background image that lets you directly edit on top of it. You can do kind of magic wand style quick selection very, very easily. And then we also go ahead and vectorize that, so you're able to then move and modify the shapes. This helps with realignment if your projector moves, but it also serves as a basis for creating a lot of the generative content. This is a scene, again, kind of demonstrating this selection process. So just clicking the bottles, flood fill, dragging on stock video, and it's instantly mapped. So instead of having to go through and actually, mask out that kind of complex form, we can just do it with a raster-based selection. So the system consists of our hardware, which is called the LF1, and our desktop software, Lightform Creator. They talk together over Wi-Fi. And it will work with most projectors across a wide range of throw ratios. So we don't do any active infrared emission. It isn't like a Kinect or a RealSense. So what that affords us is the ability to have no range limitation. So if you can see it, then Lightform can see it. So Lightform works with most projectors. It'll work with cheap $300 Pico projectors all the way up to expensive installation grade projectors. But let's talk about those for a second, because those are still kind of a massive pain point for people. How is this future of ubiquitous light projection that I described previously actually going to come about? Projectors, they're big, ugly, noisy, pretty hard to install. They're not fun. I don't know how many of you have ever tried to install a projector on a ceiling, but it's kind of a miserable experience. And some of the things that I kind of neglected to talk about in my previous slides was, where did I actually put the projector? So these slides will give you an idea of the lengths I went to in order to hide them. This one here I put behind a picture frame, but you can see there's an LED projector, an Intel NUC, and all the power supplies, there's a power cable running up the wall, all that. This one I decided to conceal inside of a pendant light. My fiance and Bradley, actually, they were very patient with me, and this was totally a fire waiting to happen. But it created this pretty cool Philips Hue enabled projection relief that I had on my wall. So it would sync with our lights, and I could change the content with this app I built. This kind of kicked off a series of reliefs that we made. This is another view of that one. This one we called Prototile 0. This was a parametrically designed sculpture that was interactive. We were tracing kind of the wireframe on top of it. It was milled out of CNC, out of a tooling foam, and then we reprojected kind of this generative content on top of it. And then this was one we did with Gmonk. This was another parametric sculpture. We debuted this in San Francisco at an art gallery, and it was part of a larger show that he had. But this was one of the first times we actually used Lightform in the real world to calibrate projection to a surface. What was cool about that too is that I didn't have to leave my laptop behind to run the installation. It would have actually been kind of difficult in this particular scenario. We just had the Lightform device on top of the projector, and we can just run the content off of that. So you still probably notice projectors are ugly. They're big and bulky and noisy. So how do we go from projectors that currently look like this to ones that look a little more like this, like traditional light fixtures? The answer, of course, is lasers and LEDs. In fact, we're already seeing projectors take much more discrete form factors. These are all LED or laser video projectors. So LED and laser light sources, they output far less heat, requiring far less cooling. The fans can be much smaller, quieter. The light sources also last 10 times longer. So instead of needing to climb up on a ladder and replace a bulb every 3,000 hours, these last 30,000 hours. So they can effectively run their entire lifetime without ever needing any maintenance. They also produce more saturated colors, and in some instances are focus-free, meaning that you don't have to have optics there, that if you're moving the projector around to focus on different planes, you would have to refocus all the time. But some of the lasers use coherent light, meaning, yes, they will damage your retinas, but they don't have to focus. So that's a plus. Also, thanks to cheap embedded computing, many of these projectors feature their own operating systems and media storage and Wi-Fi, Android-powered everything, basically. So there's no need to run long HDMI cables or have additional hardware. So something we know from just kind of being in the industry is that projectors, as we know them, are basically going to go away pretty soon. The future of the industry is definitely in projected AR and mapping. The thing is, projection just can't really keep up with OLED, LCDs, screens. I'd say, give it a couple of years, and this projector here will probably end up getting replaced with an OLED screen. Either the price will come down so much, or FITC will get so big that you guys will just have these massive 8K displays. And the current kind of cutting edge of projection mapping is leaning heavily real time. So generative content like these. So the top two are from the Ishikawa Wanatabe lab in Tokyo. So these are using really high frame rate projectors with expensive Vicon motion capture systems. They have markers on the actors' faces. The bottom one is a demo from Panasonic. They're actually developing their own sensor, which they have embedded into the projector more or less, that does very high frame rate real-time tracking. The image on the left is a pretty cool project from Harvey Moon. He is a technologist in San Francisco, used to work at Obscura. He's actually using the HTC Vive trackers, so the little tracking pucks that you can get from the Vive VR system. And those provide a really low latency tracking system that's relatively affordable. This also exists, though, outside of the high-end entertainment, and this is something that's kind of existed in PhD research for a while. I shared the stage with Jared Ficklin of Argo Design, who's been up here a couple times, and his image in the top left, he calls it interactive light, which I love, and it basically, is the next kind of wave of desktop computing that actually works its way into the environment. Dynamic Land is a nonprofit in the Bay Area that they've basically turned the entire room into an interactive display, and you can program live on your table. So, excuse me. This is actually a pretty cool one. So this is a technology from Microvision. They make a sensor. They're based out of the Pacific Northwest. And what this is showing is there's actually no difference between the projector and the sensor. They do a technology called laser beam scanning. So effectively, it's LiDAR, like you would see on a self-driving car, except the LiDAR is also projecting visible light. So it doesn't require any calibration of optics. You basically have both the sensing and the projecting happening on the same focal plane. So anyway, at this point, we're kind of solving the industrial design problems with laser and LED light engines. We are solving the lamp replacement problems, and we're solving the computer vision problems with Lightform. I'm going to quickly talk about a few questions that we typically get asked with projection mapping. So what about brightness? At Lightform, we've mapped out the LED and laser projector brightness on this kind of graph. So this demonstrates that we predict an affordable 3,000 lumen laser projector is not too far off, probably within the next couple of years. And 3,000 lumens would be more than sufficient for your average living room. A lot of the demos I was showing previously were in the 1,200 to 2,000 lumen range. But what you don't actually care about is lumens. What you care about is lux, which is lumens over area. So projectors nowadays are typically designed to cast the largest image possible. So they're spreading their light out over a really large area. This is great for watching, big screen movies or football games, but it's not ideal for a lot of the smaller types of AR content that we've been showing. So what you can do is take an equivalently bright projector, but just spread the light out over a smaller area, or take a dimmer projector that's much smaller and create a smaller image. And then you've actually got more light concentrated in a smaller area, which yields the same amount of lux. Another question we get asked frequently about are shadows. So if you're going to get up close to the content, you're going to be interacting with it, what about casting shadows and not being able to see the image? This one is actually pretty easily remedied by adding more projectors, just like you would add more lights in your kitchen. So you don't necessarily have to worry about blocking the image. So I mentioned, a few of the things that we're addressing: the vision, the industrial design, the light sources. At this point, really, all that needs to happen is somebody needs to take all of these things, kind of embed them into a single device that's integrated, and then find a way to install them in homes and businesses everywhere. It's really just an infrastructure problem at this point, which a lot of other kind of connected home devices are running into the same things. But as more, housing is built, we see this as being something that could eventually become just kind of a de facto default piece of new development. So projection is a calm technology. It lets us maintain and celebrate our analog surroundings while giving them new digital clothes. And as projected light and these sorts of interfaces continue to make their way into our homes and living spaces, we should consider calm technology design principles. So designing them to be not distracting and not demanding our attention. So I'm going to end on this slide. This is kind of like my Black Mirror screen dystopia slide, except this time I'm referencing the headset AR future vision of Hyperreality, which was a short film that kind of depicted this world in which you're bombarded with pop-ups and advertisements and spam, and you can't escape it. The image on the right, obviously, is the movie Her, which is not exactly a utopia, but it kind of depicts this world in which technology has disappeared. It's faded into the background. Other than his desktop computer, and he has like a really badass hologram that lives in his living room, there aren't really any screens in the movie. They've kind of all gone the way of this ubiquitous voice interface. And so what I believe is that with projected AR, we can achieve a future vision that is a little bit more, like the movie Her, in the sense that the technology isn't necessarily in your face, demanding your attention 100% of the time, that we have these ambient displays, these kind of ubiquitous interfaces that can be there when we want them, but can disappear when we don't. Thanks a lot.